And I said, if we want to score between 20 and 32, what topics do we have to make sure that we review? And these are what we came up with. So you guys are trying to be pushed towards, I'm aiming for that kind of that 27 spot in there for you guys, but that's where we'll be. So we start by ordering of decimals and ordering of fractions. Okay, a little bit of number sense. What's the smallest number here? 0.001. What's next? 101. And then?
0.101.
11. And then? Good. Okay, as you move along to fractions, it helps to sometimes think of fractions as mixed numbers. How do these numbers compare? Well, instead of 3/2, I could think of that as 1 1/2. What would 9/8 be then? 1 1/8. 5/4, 1 1/4, and then 1 1/99. So when you write it like that, it's easy to then compare the numbers, isn't it? What's the smallest? 100 over 99 is less than 9/8, which is less than 5/4, which is less than 3/2. I found over the years that a lot of people get the next one wrong. They don't know how to deal with percents. What's 25% as a decimal? 0.25. 1/5 is a decimal. 0.2 because it's 2/10. So 0.2 and then 0.3. So if we're going to order from least to greatest, I have 1/5 is less than 25%, which is less than 0.3. Square root of 7 is between what two numbers? Close. Closer the first time. 2 and 3. Whereas 3 1/3 is 3.33, and 5/3, what number is that approximately? 1 2/3, so 1.6 repeating. So the smallest number would be 5/3. That would be less than the root of 7, and that would be less than 3 1/3. Other things that do with number sense, they want you to be able to add matrices. Do you remember how to add matrices? Yep, we judge a matrice's size by the rows and columns. So it has 3 rows and 2 columns. So this is a 3 by 2 matrix, and this is a 3 by 2 matrix. In order to add 2 matrices together, they must be the same size, and it will produce another matrix of the same size. So I get 6, because 1 plus 5 is 6, and I have positive 2. And 0 plus 2 is 2, 2 plus 2 is 4, 2 plus 0 is 2, and 1 plus 4 is 5. That's my new matrix. You should be able to multiply a matrix by a scalar. You have a 3 by 1 matrix right here, and you simply multiply each number by 5. You get 5, 0, and negative 20. But here's the more challenging part. Do you remember how to multiply matrices?
Oh, you go across down.
Very good. Let's talk about the size first. What is the size of this matrix? It is a 1 by 3. And what is the size of this matrix? A 3 by 2. So here's what you need to understand. In order to determine if matrices are compatible for multiplication, the inside numbers must match up. So you can see the 3's match up. The outside numbers tell you the new size. So you're going to get a 1 row by 2 column matrix. That's going to be the output. And as Marissa said, we take rows, just like we measure rows by columns, we multiply rows by columns. So you're going to take this row and multiply it by this column. So 1 times 3 is, and then we add that to 0 times negative 1 is, and then we add that to 2 times 0 is. So 3 is row 1, column 1 entry. Then we take this row 1 times column 2. 1 times 0, 0 times 1, 2 times 4, and so you get 3, 8 is your new matrix. Once you remember how to do it, it's not very challenging, is it? Okay, but that's what you can gather. And by the way, I used this review for the first time last year, and the seniors gave it a very, very good response when they then took the ACT. So I decided to use it again. I've switched up things year to year just because trying to find things that work. All right, got to be able to add complex numbers. Notice that we are in the number and quantity option. So, you know, getting problems like this right, that's when you're trying to score between like 10 to 18 points. But when you're trying to get then these problems right, you know, dealing with imaginary numbers, that's where you're starting to deal between, say, the 28 to 32 points on the ACT. See what I'm saying? So that's how they break it up for us. So I've tried to grab the ones, say, hey, if we want to score high, what do we have to make sure we do? And I found those. How do you add complex numbers? Very good. Yeah, 7 plus I. That was easy. How do we multiply them? Negative 14, I squared. And I squared is negative 1, so you do get 14 then. Covered that before, haven't we? I to the 51st power. Wouldn't you agree it's I to the 50th times I? The goal is to write it as I squared. So I to the 50th is the same as I squared to the 25th. So notice if I write it I squared raised to the 25th, and then we're going to multiply that by I. Now I can figure out what it is, because you know that I squared is what? So I have negative 1 to the 25th is negative 1, and negative 1 times I is, so negative I is the correct answer. Isn't that tricky? Negative 4 divided by I, that's not in standard form. So we got to make sure that we do not divide by an imaginary term. What do? Top and bottom by I. Yep, over negative 1. And so negative 4I over negative 1 is just 4I.
Or you might put I over 51. You can also say, like, if it's odd, that it's negative, even if it's positive. Like, since 51 is odd,
So
just
just to make sure we understand that, I to the 50th and then I to the 52nd, both are even, correct?
Yeah.
But watch, this is I squared then to the 25th, whereas this is I squared to the 26th. Or in this case, negative 1 to the 25th, you get negative 1, whereas in this case, you get negative 1 to the 26th, which is positive 1. So you got to be, it's
by 2 and then check.
Yes, but divide by 2 and check, realize that we start with 51, and we divide that by 2, so it's hard to give absolute rules in that situation. Very hard to give absolute rules. Okay, locate these numbers on a number line. Square root of 7 is going to be between which two numbers? 2 and 3, so square root of 7 is going to be somewhere in there. Square root of 63 is going to be between? Yeah, you know, the square root of 64 is 8, right? So between 7 and 8, it's going to be really close to 8. How about if we have rational exponents, say 64 to the 1/2? What does that mean? Square root of 64, which is? Good. How about you have 8 to the 2/3? How do we determine 8 to the 2/3? Cubed root of 8 squared. And so I square the 8 to get? And what's the cubed root of 64? 4. So if you're right 9 to the a over b, b root of 9 to the a. Very good. Yep. All right, algebra and functions. Let's move along. We are going to set up some proportions. So you answer this question on your own. Recipe for pizza requires 5 cups of flour, makes 4 small pizzas. How many cups of flour should be used if 7 small pizzas are desired? See what you come up with. Take about 30 seconds. Go. 5, 4, 3, 2, 1. When I set this up, I like to look at flour and pizzas. You will have at least 2 to 3 problems on the ACT that involve a proportion. So I always set it up to make sure I get my labels right. Flour on top, pizzas on bottom. How many cups of flour? How many pizzas? So that's going to be equal to, we need 7 small pizzas. We're wondering how many cups of flour are needed. So X over 7. So notice I put the flour on top, put the pizzas on bottom. I cross multiply, I get 35 is equal to 4x. Divide by 4, and you get 8 3/4.
Oh, I guess 35 over 4 would be accepted.
Okay. What's that?
35 over 4.
Yep, that's fine.
That's okay.
What's that?
I don't remember anything about that.
Oh, okay. John pays $25 for his meal. He wants to leave a 15% tip. So what's going to be the total expense for his meal? Everybody's going their calculator. Can I show you an easier way to do this? So 15% would be 10% and 5%, right? What's 10% of 25? $2.50. So 5% would be half of that, right? What's half of that? So that means that $3.75 is going to be the tip, right? So the total bill is going to be $28.75. So you may not like this, but because the ACT is timed, part of it is to see how quickly you can go through some of the problems. Yep. Percentage off. A coat that was $62 is marked down 20%. What is the cost of the coat after the markdown? How are we going to figure that out?
So you take like 10%, right? And you just subtract it and add it. 10% twice.
Okay, so you could take 10% twice and subtract it. Yep. There's a number of ways to do it. So if it's marked down 20%, then what percent of value is it from its original?
80.
It's 80% of the original, right? So you could also take 8.8 times 62, and you should get, anybody? $49.60. Let's switch it. A coat is marked down 40% to $80. What was the original cost of the coat? You think about it for 45 seconds. See what you come up with. Go. So if it's marked down 40%, what percent is it of the original?
60.
So 60% times the original is equal to $80. 60% of the original is $80. So if you divide both sides by 0.6, you should get X is 133.33. Can I show you another way of doing it? Sometimes you can set up proportions as well. If it's 60%, that means it's 60 out of 100, okay? So does $80 reflect the 60% or the 100%? 80 is the 60%, so 80 over X. And if you were to cross multiply, you'd get 133.33 again. Okay? Multiple ways of setting it up. There's not a right or wrong answer, or not a right or wrong way of doing it. Words to symbols, product of 9 and X. 9x. Difference of X from Y. Y minus X. X from Y. 22 less than W. W minus 22. Quotient of 9 and the sum of X and Y.
X plus y divided by 9.
9 divided by the quantity X plus Y. Don walks dogs. Good for him. He receives $5 for the first 10 minutes, $2 for each 10 minutes after that. He receives 17 bucks. How much time do you spend walking the dog? Go ahead, figure it out. Okay, some people set this up by taking 5 plus 2 plus 2 plus 2, and they do that until they finally get to 17. I don't care. It doesn't matter to me how you do it. But the other people say, well, 5 plus 2x is equal to 17. So they find out that x is equal to 6. So that means that there were 6 of the 10-minute versions, and then there was the initial 5. So how many total intervals did he have? 7. So 70 minutes, or 1 hour and 10 minutes. Okay, we're about at that time. We'll have to pick up tomorrow.